Derivation of the cost function from a Cobb-Douglas production function. Given the Cobb-Douglas production function, where Q represents the quantity of output, A is the total factor productivity, X_1 and X_2 are the quantities of input factors 1 and 2, and alpha and beta are the output elasticities of these inputs, 0 less than alpha less than 1, 0 less than beta less than 1. We aim to derive the associated cost function. This function expresses the minimum cost of producing a specific output level, Q, as a function of the input prices. Let W_1 and W_2 denote the prices per unit of input X_1 and X_2 respectively. The firm's objective is to minimize the total cost. Subject to the production constraint, Q equals Ax_1 ⵅ alpha, X_2 ⵅ beta. We employ the method of Lagrange multipliers to solve this constraint optimization problem. The Lagrangian is defined as: the first-order conditions for cost minimization are obtained by taking partial derivatives with respect to X_1, X_2, and lambda and setting them equal to 0. Dividing equation 1 by equation 2 yields the optimal input ratio. Substituting this optimal input ratio into the production function, equation 3, allows us to solve for the optimal quantities of X_1 and X_2 in terms of output Q and input prices W_1 and W_2. Solving for X_2. Substituting this expression for X_2 back into the optimal input ratio equation, we obtain the optimal quantity of X_1. Finally, substituting these optimal input quantities into the total cost equation, C equals W_1 X_1 plus W_2 X_2 yields the cost function. Therefore, the associated cost function is, where this cost function demonstrates the minimum cost required to produce a given level of output Q, considering the input prices W_1 and W_2 and the technological parameters of the Cobb-Douglas production function. The exponent fracon alpha plus beta reflects the impact of returns to scale on the cost structure.